The last dying light of a previous universe.
In a specific year, a renowned scientist made a claim so extraordinary that most of his colleagues refused to take it seriously.
He announced that he had found evidence of a universe that existed before our own. Not as a theory, not as a philosophical thought experiment, but embedded in the oldest light we can detect.
The ghost of a dead cosmos, hiding in plain sight.
To understand why this matters, you need to know about the cosmic microwave background.
The CMB. It is the thermal afterglow of our Big Bang.
Radiation that has been traveling for nearly 14 billion years. And now fills the entire sky as a faint wash of microwave light.
Cosmologists treat it as a map of the universe's infancy.
Every major space telescope we have ever pointed at the CMB has been searching for patterns that confirm our standard model of how the universe began.
What Penrose found instead, working with Vahe Gurzadyan of the Yerevan Physics Institute,
were anomalous concentric rings of unusually low temperature variance in the CMB.
From black hole collisions in a previous cosmic aeon.
Then, in a 2018 paper with collaborators Daniel Ahn and Krzysztof Meissner,
Penrose identified a second form of evidence.
Faint hotspots he called Hawking points. Which he argued were the remnant signatures of supermassive black holes that had fully evaporated through Hawking radiation in that prior universe.
The theory is called conformal cyclic cosmology.
It proposes that our Big Bang was not a beginning, but a transition. The continuation of a previous universe's infinite future.
Conformally rescaled into our singular origin.
Multiple independent research groups have disputed the statistical significance of Penrose's claimed detections.
And the theory requires that all massive particles eventually lose their mass at the end of each aeon,
A condition that has never been observed. As of 2025, the debate remains unresolved.
If Penrose is correct, the faint rings and hotspots in the CMB are scars
Left by dying black holes from a cosmos that burned out before ours was born. And the terrifying implication is not that we are the first universe.
It is that we have absolutely no way of knowing how many came before.
Number 6. The nothing that created everything.
In December 1973, a 2-page paper appeared in the journal Nature
that proposed something so radical, The author had previously been laughed at for suggesting it out loud.
The physicist was a researcher from a notable academic institution.
And his paper carried the title, "Is the Universe a Vacuum Fluctuation?" His answer was yes. The entire universe.
Every galaxy, every star, every atom had spontaneously materialized from literally nothing.
For no reason, as a consequence of physics. At the time, the question of why the universe exists at all was considered entirely outside the scope of science.
Physics described how the universe behaved. It did not explain why there was something rather than nothing.
That was a question for philosophers or theologians, not for the pages of nature.
Tryon changed that. He argued that the laws of quantum mechanics, specifically the Heisenberg uncertainty principle,
which permits temporary violations of energy conservation over sufficiently brief timescales,
Make the spontaneous creation of a universe not merely possible, but given infinite time, essentially inevitable.
his key insight was elegant and deeply strange.
If you add up all the positive mass energy in the observable universe,
And all the negative gravitational potential energy binding it together.
The total comes to approximately 0.
a universe with zero net energy costs nothing to create.
It is, in Tryon's own words, simply one of those things that happens from time to time. Alexander Vilenkin of Tufts University.
Later formalized this further in 1982 with his concept of quantum tunneling from nothing,
Giving the idea a rigorous mathematical scaffolding. The model answers the question of origins by pointing to physics.
But physics itself then immediately becomes the unanswered question.
Quantum fields, the uncertainty principle, the laws governing vacuum fluctuations.
None of these are nothing.
They are a deeply structured, mathematically precise framework
That existed somehow before the universe they produced. Every answer reveals a deeper question hiding behind it.
If the laws of physics created the universe from nothing, what created the laws of physics?
That question has no known answer. It may not have one.
Number 5. The infinite factory of universes that never stops. In a particular year, a physicist from a specific region,
Then working between the Lebedev Physical Institute in Moscow and a prominent research center in a European city,
Published a paper titled eternally existing, self-reproducing, chaotic, inflationary universe.
The title alone should have been alarming. The content was worse. Linde had discovered, while working through the mathematics of his 1983 chaotic inflation theory, that inflation does not simply start and stop.
In most of the universe, it never stops at all.
It is happening right now. It has always been happening. There was no beginning. The original inflationary model, proposed by Alan Guth of MIT in 1980, described a brief period of exponential expansion in the universe's first fraction of a second that smoothed out the Big Bang's irregularities and seeded the large-scale structure we observe today. It was already extraordinary. But Linde found that, in quantum field theory, inflation does not terminate everywhere simultaneously. It stops locally. In isolated regions that cool and condense into pocket universes like ours, while continuing to inflate in the surrounding space.
Those inflating regions generate new pockets, and new ones, without end.
The implications do not stop there.
Each pocket universe that condenses from the inflating field can cool into a different configuration of physical law.
Leonard Susskind of Stanford University, working within string theory, calculated in the early 2000s that the number of possible configurations, distinct universes with distinct physics, is approximately 10 to the power of 500.
That number is so incomprehensibly large, it has no name that adequately conveys its scale.
Our universe, with its particular constants and forces and laws, is one random bubble among an effectively infinite sea of them.
Eternal chaotic inflation solves a profound problem in cosmology. Why do our universe's constants happen to be exactly right for stars and planets and life?
Because all possible constants exist somewhere.
And we can only find ourselves in a universe that permits our existence.
It is a compelling answer, but it arrives at a cost. It means our universe has no special status, no privileged position, no particular significance.
Somewhere in the eternal inflation field, a universe is being born right now,
with physics that make ours look like a rough draft.
and it will never know we existed.
Number 4.
The collision that became our Big Bang. In March 2001, 4 physicists, Justin Cowrie and Bert Ovrutt, of Princeton and the University of Pennsylvania, along with Paul Steinhardt of Princeton, and Neil Turok of Cambridge, posted a paper to the Physics RXiv preprint server that proposed a genuinely new answer to the oldest question in cosmology. Their theory, which they called the ekpyrotic universe, took its name from the ancient Greek word ekpyrosis, meaning conflagration.
The Stoic cosmological idea of a universe born and reborn through fire.
What they were proposing was that our Big Bang was not a beginning.
It was an impact.
The framework they used was M theory,
The 11-dimensional extension of string theory, in which the familiar 4 dimensions of space and time
Are themselves a membrane, a brain, embedded in a higher dimensional bulk space. In this picture, our entire universe exists on the surface of one 3-dimensional membrane.
and parallel to it, separated by a microscopic gap in the extra dimension, exists another.
The two brains cannot interact through any force except gravity.
Gravity leaks across the gap, and over vast timescales, that gravitational attraction
Slowly pulls the brains toward one another.
When the brains collide, the energy of the impact does not destroy them. It floods them with heat and matter.
It produces exactly the conditions of a hot Big Bang.
Quantum fluctuations in the brain's surfaces at the moment of collision
Generate the density variations that eventually become galaxies.
In 2001, Steinhardt and Turok extended the model into a fully cyclic version. The brains collide, release their energy, separate, drift apart over trillions of years.
Attract once more and collide again, endlessly, with no beginning and no end.